Yeah. They gave Lil Try to 25 for them things, nigga. They walk up on you, get her and see your friends, nigga. They walk up on you, get till you see your friends, nigga.
Hello, my name is DeAndre Wilson, aka Let's Make Calculus Great Again. So today we're going to be doing integration with partial fractions. Here's our example. 4x squared plus 2x minus 1 over x cubed plus x squared, the integral of this. So first, we will try to integrate it regularly. Our u would be x cubed plus x squared, and when you derive that x cubed plus x squared, you get 3x squared plus 2x, and that wouldn't fit in here because just won't have the negative 1. You don't know what to do. So what we have to do is you have to use calculus to get around this obstacle. So let's just rewrite this as 4x squared plus 2x minus 1 over x squared x plus 1. And keep in mind that x is reducible to x times x. So now let's just rewrite this as a over x plus b over x squared plus c over x plus 1. The reason the a and the b is because this is, once again, this is reducible. So now what we're going to do is we're going to multiply both sides of this equation by x cubed plus x squared. So on the left hand side we'll have 4x squared plus 2x minus 1 equals a times x plus 1 times x plus b times x plus 1, and then plus c times x squared. So what we're going to do first here, we're going to have to solve for a, b, and c. Well, something you can do first is you can plug in 0. When we plug in 0 on the left hand side, we get negative 1. So this is going to have to equal something. Plug in 0 to here. This is 0, so this whole a is gone. B, you get b times 1, which is just b. And then on this side, cx squared, you plug in 0, that's 0. So we found our b. So that's one step out the way. Let's put a little marker. Now we have to find out. We need c and a. So let's just try to plug in negative 1. Plug in negative 1, and on the left side you get 1. And when you plug in negative 1 here, you're only left with the c equals 1. C times 1, so it's just c. So we found our c. Now last, we're going to have to find a. Well, we can't plug in negative 1 or 0 because then we'll lose this. So we have to find another way to get our a. So we can just do 4x squared plus 2x minus 1 equals ax squared plus ax plus bx plus b plus cx squared. So now we're looking for the a. So let's underline the ax squared, the cx squared. So what do we have here? So a. So we remember this is 4x squared, x squared 4. So somehow this side of the equation has to equal this side of the equation. And we know what our c is. Our c is 1. So if our c is 1, 4 minus 1 is 3. So that means a must equal 3. So now we have our a, b, and c. So now we just plug it in and rewrite it. So we have 3 over 3 times the integral of dx over x minus, because b is negative 1, minus the integral of dx over x squared plus the integral of dx over x plus 1. So right here, when we integrate, now we just simple integration. So we're going to be left with the 3 ln of the absolute value of x plus 1 over x plus the ln of x plus 1, the absolute value, plus c. And for this equation, we can even simplify this even more to 1 over x plus the ln of the absolute value of x to the 4th power plus x cubed absolute value plus c. So here's our part 2, our second example of let's make calculus great again. So for this example, we have the integral of x squared minus 1 over x cubed plus x dx. Once again, we have to use partial fractions to solve this integral. So let's simplify this. Let's break this down. X squared minus 1 over the x squared plus 1 dx. So now we have this. So now let's just do our equals. A over x plus, this time it's going to be bx plus c over x squared plus 1, because this is an irreducible. This right here is irreducible. So now let's multiply both sides by x cubed plus x. And on the left side, we have x squared minus 1. And on the right side, we will have a times x squared plus 1 plus bx plus cx. No, bx plus c times x, sorry. So once again, we're going to have to solve for a, b, and c. So let's plug in 0. On the left side, you will have -1. When you plug in 0 on the right side, it's going to be a times 1, which is just a, and you plug in 0 to x, and this makes this whole thing 0. So we found our a. Next, we will have to solve for b and c, but once again, there's no number we can plug in for this side to make it cancel out for the over here. So let's just do what we did before. X squared minus 1 equals x squared plus a plus bx squared plus cx. Okay, so now once again we're looking for b and c. So let's see what we have here. We can underline the a. I'm not going to underline because we're finding both this time. So a and b and x squared. So this, remember, the coefficient in front of the x squared is 1. And we have our a. So this is -1. So what number of b will give us where the left side will equal 1? Well, so then we know that b needs to equal 2 because 2 plus -1 is 1. So now we have our b. So now all we left to do is find c. Well, c is cx. There's no x over here. So that's how we know that c equals 0. So now that we have our a, b, and c, we can just plug it in and integrate regularly. So first we're going to have a negative, the integral of negative dx over x plus the integral of 2x, and because c is 0, it's no point having, there's no need for that over there, for x squared plus 1. So basic integration rules tells you that this is going to be the negative natural log absolute value of x plus the natural log of x squared plus 1 plus c. And once again, because it's they're both natural log, we can simplify this even further to the ln of the ln of the absolute value of x squared plus 1 divided by the natural log of x plus c. Hope you enjoyed. Let's not play the games.